everyone. So my name's Josh, and some of my students have asked me to make some content for them so that they can revise when outside of lessons. If you get some benefit out of that, fantastic. That's great. Just so that you know a little bit about me, I run a tutoring business and have taught thousands and thousands of students. I was a teacher for 10 years, 10 years-ish. I was a head of computer science. I also was an examiner for a very long period of time. So the way that I work is I look at all of the spec points and think about all of the potential questions that could come up. And then I use my examiner knowledge to give you as little as possible to remember so that you can access those top grades. And by condensing everything, if you don't have as much to remember. So that going through this model, I think this is going to be the most efficient way that you can get the best grades in computer science. Here's the spec points that we're going to look at today. By the way, this video is all to do with Cambridge International GCSE course. I'm going to do different ones for every single spec. So if you're on a different spec, don't go on this one, go on another one because it's not going to be relevant to you. So we're going to be looking at these ones, which is all to do with the computer architecture and, the CPU, all of that kind of stuff. So looking at these 2 points here, so we've got understanding the role of the central processing unit and also talking about the fetch, decode, execute cycle. Now, you'll notice that I've put the questions in a different color to the answer. How I would recommend taking these notes is putting you doing the same thing. It doesn't have to be the same colors that I have. Red is particularly good for human beings remembering things, so that's why I've put that as the answer, but you need something bright. If you've got something bright, you're much more likely to remember it. That would be a strong recommendation from me. So these are the potential questions on these topics. So you've got describe the purpose of the CPU. At the end, you've got describe the fetch, execute cycle, fetch, decode, execute cycle. I've put in there about the von Neumann architecture. That's a potential one that could come up. And you can use the same answer for every single one of these. So the answer is the CPU fetches instructions and data from RAM, brings it back to the CPU, and decodes it, and then executes it by carrying out the instruction. A final little point that you might want to put on there is then the process is repeated, and that's talking about the fetch execute cycle. The next point is the arithmetic logic unit. Potential questions are describe the purpose of the ALU, or state and describe the purpose of two components in the CPU. This would be half of those marks in there, so 2 out of the 4 marks. So the ALU performs mathematical operations, but also performs logical decisions such as and, or, and not. So everybody gets the first mark, but they always forget the second part. Make sure you use both of those to get full marks on this question. The control unit. The control unit, again, very similar to the last question, describe the purpose of it, and then you can use this as the second half of the second question there. So what the control unit does is it performs the decoding part of the FDE cycle and sends control signals to other parts of the CPU. Understand what is meant by a microprocessor. So the question will be something along the lines of describe what a microprocessor is. And it's a microprocessor is an integrated circuit board. So I got this right off the syllabus, so they have to give us the marks for that. And then if it was 2 marks, what I'd carry on to say is that carries out the FDE cycle, and it's normally found in embedded systems. Because if you think microprocessor just means small CPU, that's essentially what microprocessor means. So relating that to the CPU, we've got, all it is we're going to put that into embedded systems, which are things such as like fridges, toasters, computer systems within larger systems that have one specific job. We also have to look at the different registers, which are, so you've got to know 5, the program counter, the MAR, the MDR, the current instruction register, and the accumulator. As you can see, what I've done is I've put the names of each of them that you need to know. I would also be saying on this one as well, I'm just going to move this over to the side a little bit just in case I'm blocking out the question. So describe the purpose of the special register, or a specific register. And it could also say state and describe the purpose of the 2 registers in the CPU, so you get to pick them. I have seen where they've got like drawing lines to the definitions. So you've got the name and then you have to match up the definition. So we've got to cover all bases, make sure we know all of them. And it's as little as possible to remember. If you find it easier, put the acronym PC, MAR, MDR, ACC, CIR. And these are the definitions. Holds the address of the next instruction to be executed for program counter. Memory address register holds the address of the current instruction being executed. MDR holds the data that is currently in use by the CPU. Accumulator holds the result of any calculations done by the ALU. And then current instruction register receives the instruction from MAR and holds instruction while in use by the CPU. Now, you can see that the definition for every single one of them, apart from the ALU really, is all very similar. So it's about holding either an address, data, or instruction. And if you remember the name, that will tell you which one it is. And then all you got to do is just remember the next current. The rest, the only thing you got that's different on those is the program counter holds the next instruction, while all of the others are to do with the current instruction data that is in use by the CPU. So again, you just essentially one definition, and then you've got all of them. The accumulator is a bit different. If you think of actually what accumulator means, accumulate means to build up. So that's like adding, and then linking that to what does the adding? The ALU. So that stores the result of any calculations done by the ALU. Okay, so the final points that we're going to do today is the buses, which is the address bus, data bus, and control bus. So they might ask you about the purpose of a specific bus, or they might ask you to state and describe the purpose of two buses in the CPU. So address bus transports addresses from RAM to the CPU. Data bus transports data and instructions from RAM to the CPU. Control bus transports control signals to other parts of the CPU. And then you've got it all in there. Okay. Little point. I'll link this. I'll do this little activity. Sort of remind you of it every so often. But once we've gone through the content, you need a way in which you can practice this information without going through this. I mean, you could use this video as a maintenance activity, but maintenance just means doing something, using activity to go over the information so that you change it into long-term memory. This is what I think is probably going to be the most efficient way of doing it. So make a flashcard with the question on the front, answer on the back. Write the answer down. Don't say it. So when you're practicing, write the answer down, because then you can compare it. And if it's not exactly the same, even a couple of words out, say that you've got it wrong and put it in a practice pile. If you get it correct, completely correct, you can put it in a good pile. Then you need to go over your practice pile lots and lots of times so that eventually you're going to have all of them in the good pile where you can just practice those every so often.